Welcome. Today's lesson is entitled Real Zeros of Polynomial Functions Day 2. The notes worksheet represents a continuation of the previous lesson. We'll just develop some more ideas dealing with zeros of polynomial functions. Why don't we start out with a review problem there, example 1 on your paper. It says, given that -1 and 3 are zeros of the polynomial function, and I've got this quartic right there, find the other zeros. Sounds great. So just real fast, want to make a connection here. If -1 is a 0, then what that means is x plus 1 should be a factor of this quartic over here. And if x plus 1 is a factor, it should divide evenly into it. And so what we're going to do is exactly that. We're going to divide x plus 1 into it. We're going to use our c value, which of course is that -1 right there. So let's go ahead and put that in, -1 as our c value. And what I want to do is break this polynomial on down, as we talked about on the previous lesson. And so make sure you have all your numbers correct. Do your synthetic division. Again, quick, efficient, perfect. Let's get it. So I've got that right there. Perfect. And we did realize, of course, that that should be 0. We were given that -1 is a 0, and as a result, x plus 1 is a factor, so it does divide evenly into it. All right, so again, just off to the side, I'm going to do this just until we really get the hang of it, but I don't think it's a necessity at this stage. X plus 1 goes into this quartic polynomial this many times, so this times this gives us the quartic, and so I'm breaking that quartic polynomial so far down into x plus 1 and x cubed and minus 3x squared plus 4x minus 12. Awesome. Now, what I want to do is go a little further with this. I knew that 3 is a 0 of this polynomial function right here, which means x minus 3 divides evenly into it. And if x minus 3 divides evenly into this, then it also divides evenly into this cubic right here. And so that's what I'm going to do. I'm going to break it down using the next c value, which is 3. So it was given as a 0 of the function, so we know we're going to get a remainder of 0 right here. So let's go ahead and pull that off. Bring down that 3. Okay, not too bad. And there we go. Looking great so far. And so just to see what happens in terms of the function at the next step, at this stage, what I have is x plus 1, x minus 3, those two factors right here. And when I broke that on down from quartic to cubic to now quadratic, that's what's left. Perfect. Now the idea at this stage, because I'm finding zeros, is -1 is a 0, 3 is a 0. What are the other two zeros that come from this quadratic? So again, this is not necessary off to the side. You can do it if you'd like, but really what you want to do at this stage is take that quadratic and set it to 0. And so that's what we're going to solve right here. In this case, it looks like a sum of two squares, which doesn't factor in the real number system, but I can go ahead and solve it. What do you say we bring that 4 on over and get x squared equals -4? And so undo the square right there, x equals, and how about a plus or minus, of course, when I undo the square, and square root of -4, obviously no real value there, but it looks like a couple of pure imaginaries would do the trick. And so when all said and done, I've got 2i and -2i as the remaining zeros. Now, I won't go ahead and kind of write it out here. I think this should suffice for our purposes, but in terms of the zeros, let's see what we've got going on, and we'll box this on up. So the zeros of this function, 2 which were given, -1 and 3. The other 2 which are imaginary, not real, but that's all right for our purposes here. We got them regardless. Okay, so 4 zeros for that quartic. Looks really nice, and you start to see the pattern here. We're using the c values. We're using them to break the polynomial on down until we get in our comfort zone. Once we do get in our comfort zone, then we just solve through more traditional means. Okay, so the question, of course, now becomes, what happens when I don't give you any zeros? So what if I didn't give you that -1 and 3 were zeros of that function? Would we have a way algebraically to go ahead and find them? So what we're going to look at here is what's called the rational zero theorem, or the rational root theorem, when we're dealing with equations. And I've laid out some functions for us, a nice little table, and hopefully sort of the structure at this table will help us develop a nice conclusion. So you'll see on your paper, of course, there's what's called a p-value and a q-value. And so we need to go ahead and put those together. So on your paper, if you would, the p-values represent all of the factors of the constant. So in our polynomial function, whatever the constant is on the end, we want to look at all of the factors of the constant. Sounds great. You'll hear me talk about the q-values. So the q-values would be all of the factors of the leading coefficient. So in standard form, we just go out to the leading term, and the coefficient there, of course, is what we would say is, excuse me, the leading coefficient. Okay, so now I've got a number of functions here. It looks like 1, 2, 3, 4, 5, 6 on my paper, and I've got 4 here and then 2 on my next slide, so I'll just take it piece by piece. I'll do a few, and then you probably will have to do a few just to kind of see. But what we're going to focus on primarily, and you could just box it up very, very lightly, you're going to hear me talk a lot about our p over q values. So in order to get our p over q values, we're going to have to get p values first, then q, and then create all of the combinations possible for p over q. So you'll see this come into play in just a couple minutes. Now we're going to use our graphing calculator to get what are called the rational zeros of the function. So remember, a rational number is any number that can be written as a fraction. So these are going to be just our really good zeros on the coordinate plane when we see them. So rational zeros, they're real numbers, and they're numbers that can be written as a fraction. And in this case, we're going to get them directly from the graphing calculator just for this investigation. All right. Well, let me show you what I'm looking for here. I'll probably do a couple of these. I'm going to do probably the first one and then the fourth one, and then maybe ask you to pause the video and try a couple on your own at least, and then we'll fill out the table entirely. Okay, so here we go. This top line here, you can see sort of each function has 4 parts, and that should match up with the 4 parts that you see up here. So that's how my table is designed, and hopefully it's pretty user-friendly. So up here, guys, we're looking for the p-values. So everybody, if you would, for right now, very lightly circle the -6. That's the constant on the back. And very simply, I'm looking for all of the factors of -6. And so we're going to include plus or minuses, so positives and negatives. 1 goes into 6, so positive and -1. 2 goes into 6, so positive and -2. 3 goes into it, and 6 goes into it. These are all of the factors of the constant as -6. So again, you're thinking of all the numbers that divide evenly into the constant, both positive and negative. This is probably the easiest way to write it. All right, perfect. Next, guys, we go over to the top right, and we're looking for our q values. So in this case, we're looking for our leading coefficient, which is 1. So put a little 1 in there if you'd like, and circle that. And we're looking for all the factors of 1, and plus or minus 1 would do the trick. Okay, perfect. So this shouldn't work out too bad, because now I want the key right here, everybody, which is all of the combinations of p over q. These are all my p values. These are my q values. And I want to create all the combinations possible. So for example, 1 divided by 1, p over q. 1 over 1 is a p over q value. And obviously 1 over 1 is 1. 2 over 1. So 2 over 1 is 2. 3 over 1. So 3 over 1 is 3. And 6 over 1. 6 over 1 is 6. So we have exactly, let's see, 1, 2, 3, 4, 5, 6, 7, 8 p over q values. Perfect. Now, guys, we want to see a connection, ultimately here, between this list and what are the rational zeros on the graphing calculator. So we're going to go ahead and graph the function. I'm going to bring this on up here and go to my y equals. If you could do the same. We're going to graph the function, and we're going to see what are the real rational zeros. So irrational values that are zeros to this function, I'm actually not concerned about. Imaginary zeros to this function, for this investigation, I'm not concerned about. Just nice, clean, rational numbers that are zeros for this function. So let's go ahead and graph that piece. I'm going to hit zoom in number 6. And notice we've got a nice cubic polynomial here, good end behavior, fall, rise, got a couple turning points in there. And if you notice, I have 1, 2, 3 real zeros of the function. Remember, anytime it crosses the x-axis, that is a real zero of the function. And in this case, if I wasn't sure, I could go ahead and figure out the second trace and go to 0. So I'm going to do that just once. I know what this one is. So if I wasn't sure that this was -3, then I could always find out on the graphing calculator, just doing a little left bound, right bound. So I'm going to do that really fast just so we can see. But you can see, of course, that that is -3. Is -3 a rational number? Absolutely. So it is considered a rational zero for the function. I won't overplay it too much here. Does everyone see that it looks like -1 is a 0 and 2 is a 0? All of those are rational values, and so I want them for this investigation. So that's -3, -1, and 2. And that's exactly what we're looking for this investigation. Just keep an eye, look at the numbers here, and then look what ended up happening for the function. In this case, these were the rational zeros. Okay. As I mentioned, I might do 1 or 2 more, just depending on, I think I'll probably end up doing 2 more and then ask you to do a couple. So let me do this one right here. Same deal. Let's maybe go through it a touch faster. Let's get P. Let's get P over Q and go from there. So P values first. Here's our constant, all of the factors of 1, not too bad, plus or minus 1. All right, let's get in a little rhythm here, guys. Circle the leading coefficient, which is 2. And so Q would be all of the factors of the 2. 1 goes into 2. 2 goes into 2. And obviously, we do want to include the plus or minuses. All right, if I create all of the possible combinations of P divided by Q, again, that's the key. That's this one right here. I've got 1 divided by 1. 1 over 1, of course, is 1. And then I have 1 over 2. So that would, of course, be 1/2. So all the combinations possible of P over Q. All right. In this case, there are only 4 numbers on our P over Q list. 1, -1, 1/2, and -1/2. Let's grab the calculator. And let's graph the function. And just keep an eye on those values from our P over Q list. And let's see what we end up seeing for rational zeros. So I have 2x cubed. How does that x squared sound? 2x, and add the 1. I'll hit graph at this stage, and it looks like I only have 1 real zero. So remember, a real zero is where it's going to hit the x-axis. And so this is the real zero of the function. I don't know if it's rational or irrational, so I'm going to let the calculator tell me. So I'm going to go second into my calculate menu and get 0. And let's just see what that is. It's not quite as clear-cut as on the last function. Oh, there it is. All right, perfect. So as you can see, it looks like it's -1/2. And guys, of course, is -1/2 a rational value? Yeah, it sure is. So, oops, let's bring that back up here. So it looks like -1/2. Cool. All right. Let's do 1 more. And then ask you to maybe do 1 or 2, and then we'll fill it in. All right, here we go. Even faster if possible. Let's go. P, plus or minus 1, plus or minus 2. Those are the numbers that go into 2. Circle the -4 for me. And let's see, I've got plus or minus 1. 1 goes into 4. 2 goes into 4. 4 goes into 4. All right, so this is a good one right here, good practice for us. And I want to create all of the possible combinations of P over Q. So here's my P. What I do is I take a P and then I combine it with all of the Q's first. So what I would personally do here, everybody, is 1 over 1. That would be a P over Q. 1 over 2. That would be a P over Q. 1 over 4. That would be another pair, I should say, of P over Q's. Good. Does that make sense? P over Q. So all the combinations possible. Then I go to my next P, and then I put it in, combine it with all the Q's. So P over Q, so that would be 2 over 1. And then 2 over 2, well, 2 over 2, of course, is just 1, so we already have that pair. And then 2 over 4, and 2 over 4 is 1/2, so as you can see, we already have that pair. So I hope this list of 1, 2, 3, 4, 5, 6, 7, 8 numbers makes sense with all the combinations possible of P divided by Q. Okay, you'll get a little practice on that piece a little later on, but hopefully that works for you. Let's graph this last one right here, at least from my angle. And then maybe we can start filling in this table and come up with a good conclusion. All right, so if you would, negative 4x cubed looks great, minus x squared, plus the x, plus the 2. I graph it. Okay, same scenario. It looks like there's only one real number that is a 0 for this function. It looks like it'd be right there. I don't know if it's rational or irrational, and so I'm going to go ahead and let the calculator figure that out. If you could do the same, that would be great. Left bound, right bound, and notice what we end up getting here. The 0 seems to be this number that just sort of keeps going on. I know it stops right here, but theoretically, this number actually continues forever and ever, and it's not going to repeat. So long story short, does this look like a nice, clean, rational number? No, it looks like it's irrational. And that's the only real 0 that I see on the graph. And so as a result, interestingly enough, this particular function does not have any rational zeros. Okay, so that sort of doesn't help us necessarily with our conclusion, but that is what happened here. Not every one of them will have rational zeros. In this case, it does not. Okay, well, here's what I'd ask you to do. Pause the video and maybe try 1 or 2 or 3 on your own. It's your call. Makes no difference to me. I'm going to come back in just a second and fill in the table, and then we'll go from there and get our conclusion. Okay, well, here's what I have. For this one, P. Lots of them. 1, 2, 4, 5, 10, 20. Okay. Q, all the factors of 1 plus or minus 1. Which means if I do all my combinations of P over Q, since it's divided by 1, that's kind of nice. So it is just 1, 2, 4, 5, 10, and 20. So that is our list, a little bigger than some of the others we've produced, but not a big deal. Now, if you graph this function on the calculator, what you would actually see is that you're getting a rational 0 at negative 5, a rational 0 at 4, and a rational 0 at 1. And notice, take a look, guys. Look at those rational zeros. Were they on this P over Q list? Most definitely. And I have a feeling that's what you're going to start to see. Stare at that if you would. And look at those rational zeros. And do you notice they always come from the list that we generated there? Okay, let's get these last couple in just so we have it. So these would be the p-values. It's always nice when q is just plus or minus 1 because then that makes p over q quite a bit easier. So I've got that piece. If I graph this function on the calculator, and maybe you did, maybe you didn't, no big deal, but you would see that negative 2 and 2, both rational numbers, are zeros of that function. Very cool. One more just for good measure. All the factors of 2, all the factors of 4, and let's see if I do my P over Q. This is a good one. And again, you're going to have an example in just a couple minutes here to practice this out a little bit. Plus or minus on that, and plus or minus 2. All right, sounds good. If you were to graph it, actually, you do see that there is a rational 0 at 2. So a very long story short here, maybe we can get this going a little bit. If there is a rational 0, was it on the P over Q list? Look at that. In each and every case, the rational zeros were on the P over Q list. Very cool. So we did a bunch of functions there to really solidify it, but I think we're ready to draw it in. So here we go. If there is a rational, and again, this is a very particular type of 0 of the polynomial function. So if there is a rational 0 of a polynomial function, let's make sure we get this in, then it must be a P over Q value. So remember what I said after we did example 1, everyone. What happens when I don't give you zeros to start out the synthetic division? Well, we're going to have to try some things on our own. And so what we're going to do is try to narrow down the field a little bit by creating a list of potential values. And those values, guys, are going to be P over Q. Okay, so let's just sort of finish this notes worksheet with a bunch of examples and just kind of get us thinking about it. You know, just piece by piece, let's build it up a little bit. So example 2 is meant to be just very straightforward, not going to scare us at all here. And here's what I'm asking. Let f of x be equal to this cubic right here. And without any math, I don't want you to really perform any calculations. You're not graphing. You're not putting anything into the function. All I want to know is it possible for the following numbers to be a 0 of the function? Okay. Well, here's what I guess I would ask. Don't write it on your paper, but see if you can just make a little mental P over Q list. So P would be all the factors of -6. Q would be all the factors of 2. See if you can make a little mental P over Q list in your head. And the question, of course, becomes is, if these numbers are on that P over Q list, then it is possibly a 0 of the function. If it is not on the P over Q list and it's a rational number, then it's not possible. Well, let's see. So guys, is it possible for 2 to be a 0 of this function? 2 is obviously rational. Is it a potential P over Q value here? Yeah, it's on my mental list. And so if it's a P over Q value, then it's a possibility. It might be a 0 of the function. Good, let's keep going. -6. P over Q. Is -6 possibly a 0 of the function? Absolutely. That's on my mental list. -1/2. Is this a possible rational 0? Is it a P over Q value? Yeah, it sure is. So those 3 starting it out are definitely possibilities. Is 5 a 0 of the function? Is it possible for it to be a 0 of the function? Well, guys, is 5 going to be on your P over Q list here? No. So without even doing any math, without plugging it into the function, without doing any synthetic division, I know that 5 will not be a 0 of the function. Okay, 1/3. 1/3 is a rational number. Is it possible for it to be a 0 of this particular function right here? Well, I don't think it would be a P over Q value because Q would be factors of 2, so 1 and 2. So I don't think that this is going to be on that P over Q list. So I don't think it's possible. So you can see that we really narrow the field quite a bit here. There's no point in trying any of these numbers because they're not going to be on the P over Q list. All right, now this one, it's a little tricky. Sorry about that. But first and foremost, is root 3 a rational number? No, it's irrational. Does our little P over Q list, and does that talk about irrational values at all? No, it doesn't say anything about it. It doesn't say that they can be. It doesn't say that they can't be. It doesn't really talk about irrational numbers at all. So for all I know, this could be a 0 of the function. Okay, the P over Q list doesn't tell me definitively one way or the other. So is it possible? Yeah, sure, it's possible that it is. We would obviously have to check and solve and so forth. As a matter of fact, I actually created this cubic function, and square root of 3 does happen to be a 0 of the function. But you would never know that from P over Q. It doesn't tell one way or the other. So just real quick, sorry about being a little ambivalent about it, but basically our P over Q list only talks about rational numbers. Doesn't say anything positive or negative about irrational numbers. Okay, well, let's get back into sort of just working with the math here. So this one was just meant to be very general in nature, just to solidify our conclusion. Let's move onward if we can. So one more time, anytime it says lists the possible rational zeros, very simply, guys, that's going to be P over Q. So what you want to do here is just create your P over Q list, essentially. And it could be just a set of numbers, and that's what it is here. I'm going to ask you to pause the video and do this one on your own, and then I'll go through it in a rather quick way. But I will let you know that I have 2, 4, 6, 8, 10, 12 values on my P over Q list. All right? Well, here's what I have. P would be all the factors of 4. Plus or minus 1, plus or minus 2, plus or minus 4. Q would be all the factors of the leading coefficient, which is 3. 1 goes into 3, 3 goes into 3. So here's what I'm after, of course, P over Q. And what I do again is I just start with a P and divide it all by the Q's. So 1 over 1, 1 over 3. Then I go to my next P and take that and divide it by the Q's. So 2 over 1 and 2 over 3. Perfect. And then I go to my next P and divide that by the Q's. Obviously, if there are any redundancies, we don't include those. But looks like 4 over 1 and 4 over 3. And there you have it. 2, 4, 6, 8, 10, and 12 possibilities. So that is what we're looking for. You'll see this phrase come up again and again, possible rational zeros. That's P over Q. Awesome. Okay. Now if you remember where we started this lesson, it was all about here are some zeros of the function, find the others. Now look at 4 and then 5 as well, by the way. Notice I don't give you anything to start with. But we're on our own, and we've got to find all of the zeros for this function right here. Okay, well, let's do it. So the moral of the story with this particular lesson is that we can narrow down the possibilities from an infinite number of possibilities. There are an infinite number of rational values out there to a select few that are possible. And that is from the P over Q list. And so what I'm going to do is create my P over Q list for this particular function right here. And I'm going to do this rather fast because it's an easy list to create. Factors of 6 over the factors of 1. So essentially it's going to be 1, 2, 3, and 6. I hope that's not too fast for you. But you would make your P over Q list. And I guess the idea is that out of the infinite number of rational values out there, there are only 8 that are possible for this particular function. I don't know which of these would work, but these are the only ones that are possible. So now what I do is I test them. And I'm going to test them using my synthetic division. So rather than plugging them in and seeing if they produce 0, what I want to do here, everybody, is use synthetic division because the synthetic division will break the polynomial on down level by level. And that's what we've been kind of talking about over the last lesson and a half. We use the synthetic division to break it down from cubic to quadratic, and then we go from there. Okay, well, take a look at the list. There are only 8 possibilities, and you can really choose any one. Personally, I would choose the easiest number on my list, which I hope you would agree would be positive 1. So we get 1 going with synthetic division. And we cross our fingers. There's only, we can only hope here. So if it works, great. We've got it and we can move forward. If it doesn't work, well, we've wasted 10 seconds and we try something else. So I'm going to try the 1. And you can get good at this. You could start to see pretty much right away, like I could see there, that this is not going to work. Because when 1 goes in, it looks like -8 comes out. I get a remainder of -8 with the synthetic division. So 1 is on my list, but is it a 0 of the function? No. So unfortunately, it's not a 0. All right, so too bad. So what's the next easiest number to go ahead and try? Well, I would try -1 personally. So I just come over here and I go -1, same deal. Okay, nice and quick. That's why we talked about that synthetic division. It's so compact, very easy to use. And look at that, we've got one. So -1 was on my P over Q list, and as a matter of fact, it works. And remember the idea, guys. What we've done is we've taken -1 and we've used it to break that polynomial from cubic to quadratic. Okay, at this stage, and you don't have to write this, I'm just kind of thinking out loud with it. At this stage, we know the cubic is made up of x plus 1 as a factor, because -1 divided evenly in. And then I've got x squared plus x and -6. Now, again, you don't have to write this. Totally unnecessary. What you want to do at this stage is take the quadratic, because that is something we're very comfortable with, setting it to 0 and solving. And so in this stage, what I would probably do is see if it factors, and it does. X and x, how does +3 and -2 sound? And we've got them. So in this case, it looks like x equals -3, x equals 2, and now I've got my factors and zeros. -1 was a 0, -3 was a 0, and 2. So when all is said and done, let me come back over here. I got a little off track. Our zeros, -1, we tried with synthetic division, and it worked. We were happy about that. -3, and by the way, everyone, -3 is a rational number. Is it on our P over Q list? Yep. And 2 is a 0. Is it a rational number? Yep. And is it on our P over Q list? Absolutely. And there you have it. Okay, so without the graphing calculator, notice that worked out pretty well. Didn't take us too long. We solved it nicely. Okay. So the next stage is to take a look at example 5. And notice the wording's a little different, which we'll get to in just a couple minutes. But it's basically find all of the roots, or really all of the solutions to this cubic right here. So first order of business, before we kind of talk about how to solve this, is let's set this to 0. So I get something like that right there. And we would certainly look to solve this through more traditional means like factoring or something else, but it doesn't look like it factors to me. So we need to find another way to solve this equation. And so the way we're going to go ahead and pull this off is using our synthetic division and breaking it on down and finding what we would call the roots or solutions here. So I don't know. The only thing we can do at this stage, guys, is get a little list going of what's possible. If there are rational solutions to this equation, they must be P over Q values. And so again, I'm going to generate this list rather fast here. Always nice when the leading coefficient is 1. So factors of 12, how about 1, 2, 3, 4, 6, and 12. So a little bigger list here than what we would hopefully want. But again, out of all the rational numbers in existence, these are the only values that are possible solutions for this equation. So really narrows the field quite a bit. Okay, again, what I would personally do is just try an easy one and, cross your fingers. If it doesn't work, try the next one on the list. And if that doesn't work, try the next one until you get it, and then go from there. Well, don't need that positive. Let me quickly erase that. Okay, and get that 12 in. All right, so let's try the 1. And shouldn't be too bad. Bring down the 1, go right there. And again, you'll be able to start to tell, like I can tell, we are in good shape. So we tried the 1, and it worked really nicely. So 1 happens to be a solution to this because it produced 0. Now, again, we use that 1 to break it on down from cubic to quadratic. And this quadratic very simply looks like this. And is it a quadratic that we can solve pretty easily? Yeah, sure. So let's do it. It factors nicely. They're going to get harder, obviously, as we go through the process here, but quite frankly, these should be pretty straightforward for you. So you can see 4 would work, -3 would work, and so what we would call the roots of this equation, in this case, we got 1 from our synthetic division. We actually got it on the first try. Yay for us. And then we broke it on down to the quadratic, and from the quadratic, we got 4, and we got -3. Are all of these values rational in nature? Sure. And are they all on our P over Q list that we created up here? Most definitely. Okay, good. So you can see that skill set really is the synthetic division to break it on down and then solve the quadratic. Well, you notice, guys, just the last piece here. I talked about the zeros for the function and the roots of an equation, but the math was identical. Just please make sure you keep that in mind. But that's really the idea. We talk about for a function, remember, is sort of y in terms of x. It's a relationship of 2 variables. We talk about the zeros of a function. And here, solving an equation, this is a 1-variable equation, and we're just trying to get the answers that balance the equation, that make it true. And so we talk about that in terms of those are the roots of the equation. So just the phrasing is slightly different, but as you can see, I did the math in the exact same way. P over Q, test a value, hope it works. If it works, keep going. If it doesn't, try something else. Okay, guys, I'll stop it right there. Thank you so much for listening. Let me know if you have any questions on it.